Welcome back to the Mechanics of Solids lecture series. We're working on internal shear and moment functions in beams. In this video, we'll complete the example that we started in the last video by plotting a shear force diagram and a bending moment diagram for the beam. It's convenient to line up our shear force diagram and bending moment diagram right underneath a sketch of our beam so that we can see how the loads line up with the internal shear and the bending moment. So what I'm doing is I'm extending lines down for all the transition regions of the beam, which would be the left boundary, the concentrated force P, separating region 1 and 2, and finally the right boundary of the beam. Dropping down a little bit, I'm going to draw an axis line upon which I'll plot my shear force diagram, which I will label V of X or SFD for shear force diagram, if you like. And I'll drop down a little bit further and sketch another axis, which I will label M of X or BMD for bending moment diagram, if you like. Okay, I'm going to go ahead and switch colors so that you can clearly see, distinguish the plot from the axis. Starting in region 1, our shear function V of X is a constant value. It's positive, so I will come up some distance and draw a straight line for the constant function. It's positive, and the value, which I will label somewhere along this region of the beam, is PB over A plus B. Okay. The moment function in region 1 is a linear function because it's linear with respect to x. Evaluating at the left end of the beam, x equals 0, we would get M of X equal to 0. And evaluating at the transition point, x equals A, we would get the value PBA over A plus B. Because it's a linear function, I can simply draw a straight line in between. Didn't quite turn out where I wanted it to, but that's okay. In region 2, the shear function is also a constant value, and it's negative. So I'm going to drop down. I know that A is larger than B, so I want this to drop down a little bit further. Is negative and equal to PA over A plus B. The moment function in region 2 is also a linear function. If we evaluate it at x equals A, notice that this term drops out and this term is the same as before. So the moment function starts out at the same value that we plotted it earlier. The moment function at the end of the beam would be evaluated by substituting x equals A plus B. If x equals A plus B, this and this would cancel out, so we get PB minus P times A plus B minus A, which reduces to 0. So also a linear function in this region, draw a straight line between the 2 points. And that's what our bending moment diagram looks like. The bending moment diagram in this case is 0 at both ends of the beam because they're pin connections, and we know that pin connections cannot carry a reactionary moment. So that's a good check on the beam, on the bending moment diagram. As we go on, we'll talk about other ways that you can evaluate your shear force diagram and bending moment diagram for accuracy.